Hello everyone. Today I am going to revise kinematics. I am an yakeen batch student, so you can revise with me. Let's start. I have done these questions. I've done this. I've done this. I've done this. I've done this. I am going to do from here. So a ball is dropped from. We will not waste any more time. A ball is dropped from the top of a building. Actually, I recorded already, but due to some problems, I have to cut the video. Okay, a ball is dropped from the top of a building, 100 tower, 100-meter high. At the same time, I'll not look at the answer now. A ball is dropped from the top of a building, 100-meter high. At the same instant, another ball is thrown to upwards with a velocity of 40 meter per second from the bottom of the building. The two balls will meet after a ball is dropped from the top. Okay, this is a tower, 100 meter. So at the same instant, another ball is thrown upward with a velocity of from the bottom. Okay, one ball is dropped from here, and another ball is like this with the same velocity, 40. Okay, velocity is given 40 meter. I have the problem to write 40 meter per second from the bottom of the building. The two balls, okay, so this type of questions, that is the two balls meet with each other, or overtake the car, or board the bus, like this we use relative motion. We have to stop one. So time, we will find a time. So after what time? Okay, we have to time find t. So for t, we have used the formula s equal to v plus ut. Okay, yeah. So now, okay, this is quite easy. So 100 meter, this is, so here we have to find velocity of a. This is, let it be a, and velocity of this is a ball a, and this is ball b. Okay, okay, next look, velocity of a with respect to b, velocity of a with respect to b. Okay, velocity of a with respect to, so from next time I'll do this in my copy. You can look. So velocity of a and velocity of b is equal to a minus b. Now b is stopped. B is now stopped. So let it be here. Let it meet at, let it both meet at here. Okay. Now velocity of a minus b. What is the velocity of a? Velocity of a is, initial velocity is 0, but a with respect to ground is, so velocity of a is 0. Yes, initially it is 0. Then minus b is, it is 40. So equal to minus 40. Then here distance is minus 100, because finally it comes downward s. And then acceleration, we have to find acceleration of a with respect to b, and it is nothing but what is acceleration of a? Both are g, minus g, that means g minus g minus g. Okay, minus g minus minus g minus g minus g, so this is plus, so acceleration is 0, means acceleration with respect to b is 0, as both are in same acceleration. So we have to find time, so we can find time by using this formula, s equal to ut plus alpha. So distance as velocity, what is the velocity, so it is minus 40 with respect to b, so they will meet after 2.5 seconds. There it is not observed where it is made, let we are actually considering them as they meet at here. So b is, now b is stopped, so they meet here. As we are using relative velocity, therefore b get is stopped, so we are finding what is the time from here to here, because here they both get meet. Okay, from next I will do this, I do this in my copy. I am pausing my recording and forming my setup. A ball is, okay, a ball is a ball is a ball is a ball rises, okay, a ball is dropped from a high rise platform at t equal to 0, starting from rest. A ball is dropped, okay, after 6 seconds another ball is thrown downward. Okay, it is simply dropped and it is thrown downward from the same platform with a speed, okay, it is, the two balls meet at 8, okay, here they meet at 18. What is the value of v? Okay, if they meet, it is quite easy also. So two balls, number we have to stop one. Okay, you try, and who can do fast, we can try together, and who can do fast. I am trying it in my. Okay, let's do it now. Okay, okay, we will do together. Okay, 1 2 3. So there is a house, okay, and both are dropped from a rise platform. After 6 seconds another ball is thrown, okay, here 2 times after 6 seconds 2 time is given. The two ball meets at 18 second, but they meet at 18 seconds, from a high rise platform at t equal to 0. So now here drop from a high rise platform starting from rest. Okay, so let one velocity, let first ball is a and second ball is b. Okay, let first ball is a and second ball is b. First ball is a, second ball is b. Okay, first ball is a and second ball is b. So first ball is going down with velocity minus z, going down with velocity minus z, and let's do it. Okay, distance covered by, actually I am posing the, and I, okay, now here distance, okay, after 6 seconds another ball is thrown downwards, so as far we have to find the distance covered by a in 6 seconds. Okay, in 6 seconds distance covered is s equal to ut plus half of a t square. So initial velocity is this distance covered by B ball, second ball, no no no, distance covered by first ball in C second. Okay, first ball in 6 second. So initial velocity is 0, so acceleration is c 10 and time is 6 square 636. So it is 180. Okay, the distance is actually minus 180 because finally it is getting down. It's correct. G is minus 10. That's okay. Distance is minus 180 as it is turning down. Now, so here for relative, so two bills, we have to find a relative velocity of b with respect to a. So a ball is moving downward. So and this is relative velocity of b minus relative velocity of a, and we have to find velocity. Now after velocity after 6 seconds of free fall. Okay, finally sir, velocity of b with respect to finally v okay go now. So look is also okay, velocity of b respect to, so velocity of, what is the velocity of b with respect to ground? Velocity of b with respect to a to will है हमें feel up and velocity of b with respect to ground. And velocity of a is speed. Okay, I have very much problem in this question. To reply say okay. To reply say velocity v. Okay, I'm pausing my recording and doing this. Okay, distance covered after 60 seconds is minus 180. And again, what is the velocity of ball A after 6 seconds? Velocity of ball A after 6 seconds, it is v equal to u plus at. So after 6 seconds it is t is 6 and g is 10. And initially after 6 seconds initially it is 0, so v equal to 60 and minus 60. Okay, velocity is minus 60 after 6 seconds downward, so x is negative. Next, s equal to minus 180. उसके बाद then okay, now we have to find relative velocity of b with respect to a is relative velocity of b. Now let a is stopped. If a1 is stopped, okay, what will be the velocity of b with respect to a? So velocity of, what is the velocity of b? Velocity of b is v, and velocity of a is after 6 seconds it is, velocity of a after 6 seconds it is 60. Okay, after it is 60, that means minus 60. Now therefore velocity of b, now s equal to ut plus half of 80 square. Now as they meet at the distance of, they meet, now distance is 180 minus 180 because they meet at and time will be here, not 6 seconds, time will be 18. It is after 12 for 18. It is after, okay, it is 18 seconds. It is given after 18 seconds. It will meet after 18 seconds. Okay, they will meet after 18 seconds and 6 seconds is already gone. So and t will be 12. So t will be 12. So 12 second 18 distance, and initial velocity of b is 0. So acceleration is okay. Initial velocity is not 0. Initial velocity is, this is velocity of, it is v minus 60, and acceleration is 0. Yeah, relative acceleration is 0. Okay, answer is 75. If you want to see the answer, you can look. This is the answer. Little bit half now. Now relative velocity in upstream and downstream. I have revised it already. Upstream means negative. Upstream means negative, and downstream is positive. V plus v1 plus v2 is. Okay, next a both. Okay, I'll do this. This is homework, but answer is not given. So we'll try. Okay, now we will try. It is homework given. Okay, we'll try now. Okay, I'll do in here. If I get tough, then I'll do in my copy. Okay, a boat takes 2 hours to travel 8 kilometer and back in still water. To travel 8 kilometer and back in still water. If the velocity of water is 4 kilometer per hour, the time taken for the going upstream 8 kilometer and time taken for going upstream and coming back is. A boat takes 2 hours to travel 8 kilometer in 8 kilometer and back in still water. To travel 8 kilometer and back in still water, it is taken 8. Still means velocity of boat with respect to ground. Time, it is time is 8 2 hours and 8 kilometer. Distance is 8 kilometer. If the velocity of water is, now velocity of water with respect to ground, it is 4 kilometer per hour. The time taken for going upstream. Upstream means negative. The time taken for going upstream. Upstream. Time taken for going upstream and coming back. So upstream means velocity of boat minus velocity of water. This is upstream. Now what is the velocity of, the time, what is the time? Okay, t. So t is speed equal to distance by time. Therefore distance t equal to distance by speed. Now distance is 8 km. Now what is the speed? What is the velocity of boat? Velocity of boat is now we can find from this. Velocity of boat is s equal to, okay, s equal to ut plus half of at square. here acceleration is 0, s is 8 and time is 2, so u is 4 maybe. This is the velocity of both with respect to river, with respect to ground. So I have problem. So answer is 2 hour. I have paused my recording and I did it and using my net. So here I have did something mistake here because it is coming and back in still. Okay, so total distance is 16. So total distance is 16. Here no about here no nothing is given about acceleration, so no need acceleration. So 16, so 2, it is 4. Okay, 16, it is 4 hour. Okay, wait, no, it is 4. Okay, speed is 8. Now speed is 8 kilometer per hour. So now here look, coming back is downstream and up. So here total distance is, here look, it is 8 no. So here 1 is 4. Here time is given by speed is 8 minus 4 divided by 8. Okay, divide by speed, the distance, and it is time. Sorry, 8 by 8 plus, sorry, is time equal to distance divided by speed. Similarly here speed will be 8 plus 4 and here speed will be 8 minus. So answer is given. We have with them and we'll get the answer is, actually I think you don't understand. You check the net and do it. Okay, let's do it. Next question, relative motion in 2D. Okay, one thing remember, I'm not here to make you explain. Actually I only do questions for my revisions, and you can do with me, you can revise with me these questions. Okay, or you can do with me, you can pause the video and solve it by using other sources. Okay, okay, now let's do it. This question, a particle, here only when I write in my copy I use this. A particle A moves due north at 3 km per hour. Another particles B due west at 4 km per hour. The relative velocity of A with respect to B is. I'm doing drawing. Okay, a particle moves due north at 3 km per hour. A particle relative velocity this is so I think you have not understood. If you don't understood, then you should refer this. Okay. Okay, next, do rain men or women problems? Factors. So here we use factors plus relative velocity. How much questions left? 1, 2, 3, 4, 1, 2, 3, 4. 4 questions left. And okay, let's do it. Okay, you can practice with me now. A rain falling in vertically downward at a rate of 3 km per hour. Rain, a man walking due west. A man walking due west opens up his umbrella. Okay. East. What is happening? Okay, a man walking due west 4 km opens his umbrella to protect himself. At what angle should the point should at what angle should he point his umbrella? Okay, rain is falling vertically down, so it means like this, like this. Rain is falling vertically down at the rate of 3 km per hour. So now, what is the velocity of rain with respect to man? Velocity of rain with respect to man. This is the main direction of the velocity. Through which velocity of rain with respect to man. If man is going like this and velocity is going like this, now what is the velocity of rain with respect to man? Then in that direction, if man opens his umbrella, okay, okay, so this is the main direction of the rain. So in this direction, if he opens his umbrella, then will not. So it is velocity of rain minus velocity of man, ground, ground. So velocity of rain is, so here velocity of man negative, so like this direction. So if man is going like this and rain is falling like this, so man should open his umbrella like this, because rain is falling like this. So actually just now I heard a news that due to COVID, both parents, means mother and father of two sons, died. So now the sons, one boy and one girl, they become you know everything has now whom they will say mama or papa. So that's very bad news nowadays. Okay, let's we continue our discussion. Actually, I paused the video and I went somewhere because I get tired, so I took some rest, and after then I okay, let's do this. Okay, I have already maybe concept done the concept, so now I have to do the only questions. So here is nothing else. So it is so 3 kilometer. So it is east at the vertical downward. So rate of 3 kilometer per hour. When walking to west. Okay, this is 3 kilometer per hour, and this is now minus 4 kilometer per hour. So finally, what will be this value? Answer will be what? It is nothing but 4 plus 16 vector 9 plus 16 plus 9 25. Answer is 5. It is 5. So this is 3. So this is 3. This is 4, and this is 5. What is the angle with respect to rain? This is the angle, or now with respect to rain, this is the rain. This is also angle, but both are equal. So now what is so this is 3, 4, 5. So it will be what? 57 degree. You should remember this. 57 degree maybe. Oh sorry, 53, 53. 37 and 53. 37 and 53. So it is 53. 53. So at what angle? It should take 53. This is what? 53 degree of south. 50 degree. Okay, east. Okay, to vertical. 50 degree of east to vertical. 50 degree of east to vertical. No. 50 degree of vertical. I am saying here also. Of means to in which 50 degree of vertical. 50 degree east of vertical. Okay, or 50 degree east of south. 50 degree 53 degree east of south, or 50 degree east of vertical. West. Oh, the main answer is so. That's why I'm taking this angle also. Now this is like this. Okay. Yeah, this is so. Actually, rain is coming this like this, but umbrella like this. So it is off 53 degree of 50 degree west to vertical. Okay, west to vertical now. So that's why west to vertical. Okay, let's do. So actually, I'm not explaining you because I don't know how to explain. I'm not a teacher. Okay, I'm now NEET aspirant. I'm going to give NEET 2021, and I am revising now. That's all. You can also revise with me if you are NEET aspirant, or if you are not a NEET aspirant or other, you can revise. Okay, just with me, but not my questions, your questions. You can you get inspiration. Okay, if you don't want to study, you can get inspiration from my this reading. I know, because if we are not reading and we saw another person who is reading, then something inspired us from it. So that's why I'm making this video. Actually, I am not making this video for this reason. I'm making this video because sometimes I don't want to study because of many reasons. Okay, then I make videos. So I'm studying also. I'm studying also, and I'm studying also and reading also. I'm studying also and making video also. So if you are inspired, a little inspired, so it will, if one person also get inspired from my video, I will feel that my video has some worth. Otherwise, nothing. I'm not doing this for my views or subscriptions. I'm doing this for my own only, to study myself only. So you can also study with me. Okay, that's all. Now next question. A man is walking. For this you have to know how to make this one east. Always this one east, always this one west, always this one north, always this one south, always. So a man walking due east. Okay, a man walking due east with 3 km per hour and observes rain falling vertically at the rate of, okay, vertically, this is rain falling, so this is rain falling, it is also 3. Next, find the actual speed and the direction of the rain with respect to the vertical. Now it is asking me, so now actual speed of the rain is actual speed of the rain. Now velocity of rain with respect to observer, with respect to observer. Okay, a man walking due east. Okay, this is east. A man walking due east with 3 km per hour observes rain. Okay, yeah, here it is giving velocity of man with respect to observer. It is given 3 km. Okay, now velocity of man with respect to observer is velocity of rain with respect to ground and velocity of observer with respect to observer. Okay, with respect to ground. So we are given this one with respect to ground and velocity of rain with respect, this we have to find, and we have this one and we have this one because it is 3 km, no? So it is finally velocity of rain with respect to ground, it is plus, so v ro plus v oz. Yes, rain with respect to ground. Okay, okay, with respect to observer. Now this is plus, so we don't change the direction. Okay, as it is it is rain with respect to observer, it is this one and this is this one, so finally this will be the actual velocity of the rain. In this answer, whatever the answer, but it is should be of east, no, of south, so velocity of rain is east of south. Oh, not given. Okay, here it is, look, answer is like this. No, this is not the velocity of rain, this is that umbrella. Okay, actual velocity of rain is plus, therefore we are going to solve like this. Okay, here direction is not written, here it is minus only because of this is in downward direction, but look, me is same, my drawing is same, maybe downward direction and this one. Here only because of downward direction it is written as minus and nothing else. But this is the direction, final direction, it is sure. Okay. Now a standing man observes rain falling with velocity of 20 meter per second at an angle 30 degree with the vertical. Find the a standing man observes a rain falling with a velocity, okay, Find the velocity with which the man should move so that the rain appears to fall so that okay, a man listening observes rain falling with velocity of rain with respect to man. He observes no 20 meter per second. Okay, with the and angle is okay. Angle is like this with vertical. Okay, with vertical. Okay, like this. Okay, this is 30 degree with vertical. Find the velocity with which the man should move. Okay, so that the rain appears to fall vertically to him. Here it is something like opposite. So that appears that so let so this is the velocity of man and this is the velocity of rain with respect to ground g, and this is the velocity of man with respect to ground. So velocity of rain with respect to man is equal to velocity of man with respect to ground minus velocity of okay, velocity of rain with respect to ground minus velocity of man with respect to ground. So we are given this one, therefore velocity what we want velocity of man with respect to ground, so that if